Good morning, gentlemen. I will make a short presentation of our computer program NextGen. NextGen is a software for pressure vessel and heat exchanger design according to ASME Section 8 Division 1, ASME Section 8 Division 2, and EN 13445. Now, under an existing project, which is, for example, this one, test project, we will create a new item. The new item is a vessel. The vessel will have a new name, V201, for example. The calculation code, as you see, can be selected also considering the preceding issues of the code. Now we will select the latest edition of ASME 8 Division 1, edition 2013. The reference publication is the metric database, material database. The input data units, megapascal centigrade. Then something about geometry. Geometry is a horizontal item, so test, hydrostatic test using the design pressure as reference pressure. Jacket, there is no jacket. Insulation, we will not consider insulation. WRC is an option for the calculation of nozzle loads according to WRC bulletins 107297. The support, there is the same option for the support, some new features about, some additional features about reporting, and then operating condition. We can select the design temperature, 215 for example, internal pressure 2.5 megapascal, that is 25 bar, and then we save this data, and now we can start building our vessel, starting from the cylindrical shell. The cylindrical shell we must establish, of course. We have made a small, must make a small amendment. We have under conditions joint efficiency 0.85. Because this is there is a weld on the shell, of course, therefore we have to select a joint efficiency, but we do not want to apply this to every component, so we say no. The geometry is first of all the material. The material, we open the database. Opening the database, we can, for example, try to select a product form. We select only a plate, only plates. Material types, only carbon, manganese steel, or fine-grained steels. And so we will find at once the material we need, which is an 516.70, this one. And the geometry, the length is 3 meters, 3000. The thickness, say the diameter first of all 1200 millimeter, and say a thickness of 15 millimeter. Now we can see that, we click on the traffic light, we will see that this is the required thickness. Maybe it's too small. There is a reason for this, because we have forgotten to add a corrosion allowance. Well, for carbon steel this is normal, so we come back to the item properties here in order to have this corrosion allowance for all the possible operating condition. Joint efficiency, generally speaking, is 1. Corrosion allowance is not 0, but say it's at least 1 millimeter. We update the item properties. Now we come back to our cylinder, looking at the report, a small report. We will see that it's something more now, but the thickness of 15 millimeter is always adequate. Then we have to confirm, and then we want to close with an elliptical head from one side. We say OK. For this case, the joint efficiency is 1 correctly. You see there is already a triggering traffic light, because the program has automatically selected the same diameter, of course, the same material, and also the same thickness. Maybe with the thickness Well, it could be somewhat less. It could be 13 millimeter, for example. So we change the thickness, say 13 millimeter. There is also another small modification because we have all elliptical ends have a flange length, say 50 millimeters, with the same thickness of the head. Okay, everything is always okay. Here we confirm, and the cylindrical shell, the elliptical head has been created. And if now we want to put a nozzle on this elliptical head, standard nozzle, so we must always go to the database and select a nozzle material. Specification number, which we know already that will be an SA106 grade B, and the under tolerance will be fixed automatically when we choose, in the pipe database, we will choose, say, a standard nozzle, say, of 250 to 273 to a 10-inch nozzle, standard 9.27. So the nozzle 8 maybe is 300 millimeter, and the reference diameter is inside diameter. Okay, everything is okay. We have to establish the position. 0, 0 is the center, radial. Welds, say we put an 8 millimeter corner weld, but we see at once that there is a problem, though the internal pressure opening is not adequately reinforced, so reinforcing elements must be added. If we want to see the situation somewhat better, we have a required area of 2,265 square millimeter against an available area of 1,075 millimeters. So this will require certainly a reinforcing pad. So we have simply to add this reinforcing pad. We say yes for the pad width, say 100 millimeter, for example. The pad thickness, we say the same thickness of the shell, 15 millimeter, and the pad material, if we click with the right click of the mouse, will indicate all the available materials. And also in the welds we have to add, because there is a further weld, 8 millimeter. Well, okay, green light. We see now we have more than required, but there is no meaning in decreasing the width of the reinforcing pad, because the cost of the reinforcing pad will be almost the same. We close and we confirm that there is a nozzle with a pad. On this nozzle, possibly we can add a flange that will be always a welding net flange with the same. We have to check on the database for the flange material. The flange material SA105. Okay. Geometry. Well, if it is a standard flange, we have to select which kind of flange it could be. Say, for example, a 300 series flange, maybe also with 150 it is possible. We check, of course, because the rating of the flange is also checked by the program. It's a 10-inch flange. The bolts, so the bolt database, we select 193 B7. So all these dimensions are fixed now because it is a standard flange. The gasket, we must find a suitable gasket material, say spirally wound stainless steel. Possibly also we will have a standard gasket, at a 10-inch standard gasket. Okay, there is a problem here. Maybe internal pressure, say the report, internal design pressure is this greater than maximum ANSI pressure, so the series 150 is not adequate. We have to change something. So close, come back to the database of standard flanges, select, and we change the series, say 300 series, and not B for 1647, B16.5, then it is a 10-inch flange. Okay, now everything is okay. You see, if we click on the traffic light, we will see that the calculation pressure is adequate in either for service or for design. So now we'll have also the flange. Now something is missing, but of course if we want to close on the other side our vessel, it's simply to say that we have to copy to a spherical head 1, and we have connected. Do we also want to copy connected components? And no, I don't want to copy also the connected components. I will copy only the nozzle. Would you like to edit it now? No, I don't like it. If it is equal to the other one, I have no problem. Okay, we have made a vessel. We could go on adding suppers, nozzle, everything you like. We could also add a liquid level, but just to show how the final report is made, you see all the green flags means that all the components have been verified, because one of the characteristics of this software is that every time you make a modification on one component, the entire vessel will be checked again and all the components are calculated again. So the report will contain a summary with a small photo of the vessel, a table of contents, the calculation of the test pressure, which is based on the maximum allowable pressure of every component, the weights of every component, the bill of materials, the nozzle connection, very simple in this case because there is only one nozzle, the minimum design metal temperature, and then you have the calculations. So you can select also the characteristics of to be written on your design report. The design report is made in double units. You can choose to have only in single units, either metric or customary. There are all the formulae that have been used, the code formula that have been used, the reference with the ASME publication, and everything what is required to present to the authority your calculation report. Okay, gentlemen, I thank you very much for your attention.